Okay, in this video, we're going to begin to talk about ionic compounds. Now, in order for an ionic compound to form, or an ionic bond to form, it has to be between a metal and a nonmetal. Just remember on your periodic table, everything to the left of this staircase is going to be our metals, except for hydrogen. Everything to the right is our nonmetals, including hydrogen. And also don't forget that this periodic table helps us identify how many valence electrons there are in any given atom. Now the transition metals get a little finicky, and you might have to draw the electron configuration to remember how many are there. But actually you don't even have to worry about that. For this problem, I'm going to use magnesium. Magnesium is in 2. That means it has 2 valence electrons. I'm going to use chlorine. Chlorine is in 17, which means it has 7 valence electrons. Remember on the periodic table that you don't have these A groups. So just remember that take the 1 off, and that's how many valence there are. So what I've done is I've gone ahead and I've drawn these E-dot diagrams. And I just kind of want to show you how these bonds are formed, how these ionic bonds are formed. Well, each atom wants to fulfill the octet rule. I'm going to write it off to the side. And that just means that each atom is, unless it's a noble gas, is unstable. And to become stable, it needs 8 valence electrons. Right now, magnesium has 2. So it's either going to give or lose to become stable, and it's going to do whichever number is smaller. So magnesium could gain 6 to make 8 or could lose 2. So it's going to lose 2. And what's going to happen is it's going to give those away, but it doesn't just go to outer space. What happens is it finds something that needs that electron, like Cl, and gives Cl 1 because Cl needed 1. Now, when that happens, Cl becomes a -1 charge because it's gaining something that is negatively charged. Now, Cl has fulfilled the octet rule. This Cl molecule, or not molecule, but this Cl ion is stable. But magnesium is still not stable. So you kind of have to remember in real life, we're never really just dealing with one atom at a time. It's going to be a whole bunch. So another Cl exists somewhere. And that Cl has 7 valence electrons. And this magnesium is going to be like, hey, you want my valence electron? Because I don't want it. And this Cl becomes a -1 charge. Well, magnesium has now given away 2, so it has a +2 charge. Now, when you write these correctly, your magnesium has nothing around it because it lost 2. And each of your Cls have 8 valence with a 1 negative charge. And negatives don't like each other, so you'd really place it over here just to kind of show that the positives and the negatives are attracted to each other. How you write this as a formula is it took a ratio of 1 magnesium to every 2 Cls. So you put a little 2 down on bottom. And this is how, your metals are losing electrons, becoming positive. We called this cations. Our nonmetals are gaining electrons. They become negative, and we call those anions. They're doing this to fulfill the octet rule, and the ratio that it takes to make them stable becomes your formula. So this little number down here represents the number of atoms that you have. So I have 1 magnesium and 2 chlorines, and that's the ratio that it takes. All right, I'm going to do one more, and I'm going to model, and it's going to be Al with S. Now, the reason I'm doing this one is it can get a little complicated, and that's okay. So S needs to gain 2. Well, it's going to take 2 from aluminum. Well, aluminum's still not stable, so I need to add one of the opposite. So I'm going to add another S. As an atom, it has 6. It's going to steal one of those. Now, this one's good. It has a +3. This has a 2-. This one, not stable yet, so it's going to add another one of the opposite. So you'll notice that it kind of just goes back and forth a little bit until everything has fulfilled the octet rule. So this becomes a 2-, but Al is not stable now, so now you add another one of the opposite, which happens to be an S. Trying to switch colors here for you. This one has now become stable with a 3+ charge, and this one has become stable with a 2- charge. It took 2 ALs, so your ratio would be 2 Als for every 3 S's. And then that's how you can kind of show it with your Lewis dot diagram. So now you're going to practice and get checked off by the teacher, me, and I want you to show me with magnesium and oxygen on your own piece of paper, and I want you to show me with strontium and bromine. Show me those 2 practice problems to move on.